And God said, "Let there be light." And there was light. And God saw the light, and it was good. And God divided the light from the darkness. And God called the light day, and the darkness he called night. And the evening and the morning were the first day. The second day. And God said, "Let let the surface integral of f dot ds, where f of xyz equals 3xy squared I hat plus x e to the z j hat plus z to the 3k hat s is the surface described. Let that be the surface described by the cylinder y squared plus z squared equals 1, and the planes x equals minus 1 and x equals 2. And he saw the equation, and it was bad, as it was unsolved. And so, in the third day, he created Julian for him to solve the equation. "Solve this equation, my child," he said. And so he did. Alright. As you can see, I have been commanded by God himself to solve this equation. And so I shall. And so he did. So first off, what we want to see here is that this is a surface integral, yes. But we can see that there is a cylinder defined here. And that means that this is a volume. So it's a triple integral, actually, not a surface integral. It is a surface integral, but inside of a volume. So what we're going to do for our ds is that we're actually going to use Gauss' theorem. For that, we need to find two things. The divergence of f, and, if I am not mistaken, yes, the dv. Wait a minute. ds and ds. All right, yeah. We're gonna find the ds is gonna be replaced by a dv because it's a volume now, and the divergence of this. So first off, the divergence. Let's just do delta. I don't know how this is called. I think it's called delta, but delta is the. Oh no. Okay, there we go. Okay, so this times f. This dot f, which is going to be equal to the I 3xy squared over partial derivative of this over partially derivated by x plus x partial derivative of x e z partial derivative of y plus partial derivative of z to the 3k partially derivated over, wait, actually this doesn't exist, over z. Alright, so with that, what we're gonna do is just solve it. This is going to be equal to 3y squared, and this is going to be equal to 0 because y is not in here, plus the derivative of z, so 3z squared. And this is simplified to 3y squared plus z squared, in parentheses, of course. All right, so that's the divergence. Now for our cylinder. To find our cylinder, we're gonna use three integrals, which means that we're gonna integrate from. Okay, yeah, let's just do it. So first off, we're gonna establish our function r. Should I call it r? I'm not gonna call it r. We're gonna call it
W because I want to. W is going to be equal to x because that's how x works. This is just a linear function. So x, comma, y is going to be, oh, right, I almost forgot. We're gonna have our y and z, because, okay, wait, let me explain cylinders. Because of the fact that this is a cylinder, we can simplify the x and the y, which would be this, as r squared equals the radius squared. So this here is going to simplify directly to r equals 1. The radius of this cylinder is going to be equal to 1. And for y, and if we do this with polar coordinates, y is going to be equal to r sine theta, and x is going to be equal to r cosine of theta. But we don't have x here. We have z, because this cylinder is extruding over x. This should be spun. There we go. That's our cylinder. So what we're gonna do here is that we're gonna replace x with z, and that's it. So that's why we're gonna have here, for y, it's gonna be r sine of theta. And for z, it's gonna be r cosine of theta. And that's it. Now we're gonna do w of x, w of y, no, actually, w of the radius, and w of theta. So here it's gonna be 1i and nothing here. So just I. Here for r, it's going to be 0i plus sine theta plus cosine theta. And for theta, it's going to be 0i plus r cosine of theta, cosine of theta, plus r minus r sine, because it's a derivative of theta. That's it. That's our three things. How do I do a triple cross product? Wait. Hold up. Wait a minute. Okay. Oh my god, how did I do this? So, Oh, wait a minute. Oh, we don't have to multiply here. Oh, that makes sense. Okay. Sorry, my bad. We didn't have to do any of this. I'm dumb. This is for normal surface integrals. This is a volume integral. So now we only have to find the limits of this. because of the fact that we replaced, I'm sorry about that, because of the fact that we replaced y with r sine theta and z with r cosine of theta, we're going to have our limits be, for x, it's going to be from -1, okay, so let's just do it here, equals, for x, it's going to be -1 to 2. For r, it's going to be from 0 to 1, because we know that the radius is 1, because r squared equals 1. And for theta, it's going to be from 0 to 2 pi. And there we go. And now, we're going to take this function, this baby right here, and have 3 y, which is actually r sine theta, r squared sine theta squared, plus r squared cosine theta squared dx r dx dr d theta. And that's it. So we're going to solve this. We can see here that r sine squared plus cosine squared is 1. So we can just simplify this. Integral from 0 to 2 pi. Oh god, alright, so horrible. 0 to 1. Integral from -1 to 2. And here we have 3r to the 3 dx dr d theta. And we can separate this. Hell yeah, because there's only r here, so we can just do this. So it's going to be integral from 0 to 1 of 3r3 dr. And because this is just from 0 to... Yeah, okay, so from x is just going to be 2 minus 1. It's going to be times 2 minus 1 times 0 to 2 pi, which is just going to end up being 2 pi. And this we can turn directly into, so the integral of this, it's r to the 4th power over 4. Okay, so it's going to be 3 over 4 r4 evaluated from 0 to 1. So it's just going to be 1 times 3 times 2 pi. We simplify this 2 because this is 2. 2 times 2, and we'll simplify one of them. So it's going to be 9, if I'm not mistaken, by any chance, 9 over 2 times 1, which is just 4.5, I think. Let me check. Oh shit. Right. I just saw the pi. I forgot the pi. 4.5 pi. And that's our result. Wow. I hope God blesses me because of what I have done here today. Bless the Lord and His work. It's a joke. I'm sorry. Yeah, I'm sorry. Okay. Thank you so much for letting me deliver this late because I was so stressed yesterday because of the exams. I will get to studying after this, actually, after I finish editing it. But thank you so much, teacher. Have a good day. Good day.